I had a question come in about this exam style question, just getting a little bit more advice on it. So I'm going to record a short video that'll help to explain that a little bit more to you. Let's have a look at the question first of all. Study the diagrams which show the position of the thermocline, come to that in a moment, in a normal year and in an El Nino year. So we're doing a compare and contrast here. The command phrase to describe what is happening and explain. And what is it that we're having to describe and explain? The contrasts in the thermocline position. Right, anytime you're approaching a question, it's important to deconstruct it like that. The first thing that we notice is that there's a term in here called thermocline. So we have to, in the first instance, define what that means. And here's the definition. It's an abrupt temperature gradient in a body of water. An abrupt temperature gradient. We'll get this right yet. An abrupt temperature gradient. A gradient is something that changes over space or over time, but this gradient is abrupt. It's a sudden change in temperature gradient in a body of water, like the ocean, marked by a layer above and a layer below, where you have water at very different temperatures. So a sudden change between warm and cold temperatures in a body of water. Let's take a look at these diagrams here. What you should know from your theoretical understanding of El Nino is that during a non-El Nino year, during a normal year, you have the easterly trade winds, which are pushing the warm water from the east towards the west. This leads to a build-up of warm water from the west. So the thermocline then just shows you where you get difference between the warm water and the cold water. We'll just add that in. That's your warmer water there. And underneath, it's your colder water. Now what happens in an El Nino year is that either you get the weakening of the easterly winds or the reversal, and then you get the water moving from the west to the east. If we look, see if you can figure out from those lines what that is showing. So let's mark it on again. There's the thermocline, right? Mark on the warm water. But notice that the thermocline dips down there at the end. You're going to get more warm water here than you did here. We'll mark on the cold water again. There we go. Well, with that colour in, that really just helps you to spot the difference a little bit more in terms of what those two diagrams are showing. So there is our abrupt change in temperature, going from warm to cold. Warm to cold, that's your thermocline. Back to the question. Describe the contrasts in the position. Let's just link those up so that they're nice and clear for us. Describe contrasts in position. So, what have we got to help us with this? We have here the dotted line, which is showing you the mean thermocline. So that's where the thermocline on average is. That's the dotted line, and then there's the solid line. So let's start with this diagram here. If that's the average thermocline, what this is telling us is that in a normal year or non-ENSO year, the thermocline is a little bit deeper than average in the west. See that? The solid line is below the dotted line, a little bit deeper than average in the west. And it's a little bit shallower than average in the east. The solid line is above the dotted line. You take a wee look at this diagram. Let's compare, I'm going to put a circle around them again just so we see what we're comparing. Let's compare this with this. What are the differences? Pause the video and have a think. Well, in the case of a non-ENSO year, normal year, the warmer water goes a little bit deeper than the average or mean thermocline. In an El Nino year, the warmer water is slightly shallower than average. There's your describe contrasts in the position. Deeper than average in non-ENSO, shallower than average in ENSO. So the western side, that's the difference. That's describing the contrasts in position for the western part of the Pacific. What about the eastern part of the Pacific? Let me just pick a different color for that. Let's have a look here. First of all, this area. Well, there's our dotted line, which represents the average thermocline position. There's the solid line, which tells us that it's slightly shallower than average. What about over here? Okay, well, it tells us about the average position. It's not even just slightly lower than average. It's considerably lower than average. You get a build-up of the warmer water here. Slightly shallower than average here. Considerably deeper than average here. So, slightly deeper than average here, slightly shallower here in the west, slightly shallower here in the east, significantly deeper here in the east in an El Nino year. So that's describe the contrasts in the position. The final part of the question then is to explain those contrasts in the position. Why is that the case? Well, we've already actually alluded to it at the start of the video. In a non-ENSO year, you've got your your easterly trade winds here, which is causing the warm water to move here to the west, which is causing a build-up of warm water here, causing it to be slightly deeper, and a deficit of warm water here, causing it to be slightly shallower. When you get an ENSO year, El Nino year, you get either the weakening of the trades or the reversal of them, which causes the water to move from the west to the east, reducing the amount of warm water here, making it not extend down as deep, leading to a surplus or build-up of warm water here, making it deeper. So that's your thermocline, your abrupt change, showing where the warm water is. The question is to describe the contrasts in the position. Notice how I did that, comparing green with green, blue with blue. That's a good way of structuring it. Then move on to the explanation, referring to the winds and ocean direction currents, and the winds and the ocean currents